Hi, boys and girls. It's your chemistry instructor yet again. Today I thought I'd talk to you a little bit about the beauty of limiting and excess reactants. Perhaps you should write that down. Limiting and excess reactants. They are two different things. There's a limiting reactant and an excess reactant. Before you were here, I carefully measured, this is exactly 0.32 grams of magnesium. It's magnesium wire, 0.32 grams of magnesium. Write that down. The reason we need to write that down is because that is a known. Right here, I'm going to use hydrochloric acid. You would not touch this, you would not breathe this because it's toxic. Also found in your stomach. I'll use a liberal amount and you will notice something. Something that indicates that there's a chemical reaction occurring. What do you notice? Yes, you're correct. Vigorous bubblage. Very nice. But now the bubbles are gone. And so is the magnesium. Intentional or big accident? That's the question. The magnesium is what we call the limiting reactant because it governs how much product we can make. When the magnesium ran out, did you notice that the bubbles stopped? Write that down. Let us go to the board. Let us calculate a little bit more closely so that we can see exactly why we call it the limiting reactant. So the magnesium was the limiting reactant. I'll abbreviate LR, and I'll put excess right there. That means there's a whole bunch left over when the reaction's done. Can we not do that? That would be really great. The excess reactant means after the reaction's done, there's going to be some left over. Okay? Did you notice there's hydrochloric acid in that beaker left over? We did that on purpose to make sure that we reacted all of that. If I can react all of it, then I can make an accurate prediction about how much product I should be able to make. So, the real question is that right there. And I gave you the amount of magnesium. What was it? It was 0.32 grams. Now, let's go over here. Step one, balance the reaction. Is it balanced? Now it is. What's step two? Do we have moles? Do you know how to change that to moles? Well, let's change it to moles. Use our periodic table. We'll go 0.32 grams of magnesium that's grams, that's moles. One goes there, that's 24.305. Somebody tell me what 0.32 divided by 24.305 is. Quickly.
What was the question?
0.32 divided by.
What'd you get? Come on, guys, quick.
I got 0.013.
0.013 chickens?
No.
Moles.
Moles. Good, of magnesium. Oh. Now we're going mole to mole ratio, right? Step 3. That's magnesium chloride. There we go. Have to fix that. And what are the coefficients? 1 and what? 1, right?
Yeah.
That's gone. Guess what my number is? Same thing, 0.013 moles of magnesium chloride. Let's give her a name. We call that, boys and girls, the theoretical yield. Theoretical yield. That means predict how much product you can make based on the limiting reactant. That's what theoretical yield is. That means how much could you make? So when you do your simulation, you're gonna notice one of the reactants is gonna run out. And that's what's gonna determine how many sandwiches you can make if you look at the the simulation where you make sandwiches on the, okay, well, if I don't have enough of one of, if I got 5 pieces of bread and 30 pieces of turkey meat, I can only make 2 sandwiches, right? Or let's say 4 pieces, let's make it even. Because the 4 pieces would make me 2 sandwiches and then there's no more bread left, right?
Yeah.
That's how this works. Like one of them ran out. You saw it with your own eyes. Which one ran out? The magnesium ran out, so the reaction stopped. If I had more magnesium, the reaction would have kept going. The limiting reactant determines the theoretical yield. You should be ready. That's why we care about it. We have to be able to predict how much product we can make, or we're no better than just some 2-bit trumpet player on the corner under a bridge or something. We're just making crap up. We're not making crap up. We're using the limiting reactant to make an accurate prediction of how much we should be able to make. Now, should be able to make. You know what that tells you?
And you might not always make them.
You're not gonna actually do just exactly. You wouldn't go back there and get that exact number. There's a lot of reasons. We won't go into that in this particular course, but just understand that this is like breaking the 3-minute mile. In theory, you could, but you won't. Am I making sense here? It gives you a target to shoot for. It lets you know how good you are. So like in a real school year without the masks and, you know, social distancing, we'd actually do a lab. You'd predict how much you could make. You go back there and make it, and then you get the mass of it. You compare and see how close you really were to that.